All right, moving on. Let's do some more examples on ellipse. In our previous examples, we were given characteristics about its graph, and we sketched it and then found the equation. Here they give us the equation of ellipse, and we want to find the characteristics so that we can graph it. So with this equation, we're given 9x squared plus 4y squared equals 36. So you'll notice it is a sum of two squared terms, but the coefficients of those x squared and y squared terms are not 1, right? They can't be reduced to 1. They're not the same. So it's not a circle, it's an ellipse, right? Key characteristic. With that said, let's get it in standard form. So to do that, right, we want to put it in standard form, right? Let's write down what our standard form equation looks like. All right, we have x minus h squared over a squared or b squared plus y minus k squared over b squared or a squared equal 1. So again, these can switch up, depends on, like I said, which is the larger denominator, which is the axis, horizontal or vertical. So with that said, our first step, if I was working this equation, right, step 1 would be to set it equal to 1, right? That would be our first step. So I would divide a 36 on both sides. So with that, what would we get? We would get x squared over 4 plus, we reduce here, 1/9, so y squared over 9 equal to 1. So we divide out 36 on both sides if we need to set it equal to 1. Well, now we're done. We already have our standard form equation. Now you notice the larger two denominators, right? A squared, and here's b squared. So remember, a is greater than b. So with our ellipse, we have h and k. What's subtracted from x? So what's our center? Let's go ahead and talk about the center point. So whatever's subtracted from x, so it's 0. We have nothing subtracted from x. X minus 0 is x squared. Same thing with y. Y minus 0 is y, so we have 0. And again, with the value of a, let's go ahead and talk about the vertices. So the vertices, we need that value of a. So what does a equal? That's our question. So let's go ahead and write that in here. So a, what does it equal? All right, so remember, a squared is 9. So if a squared equal 9, we'll take the square root and get a value of 3. So a is equal 3 units. Now with y being with y, so with a with y, that means we're going to go up and down 3 units. We know our major axis. Remember, I'll make that note here beside it. Our major axis is vertical. All right, so up and down. So if a been with x, we go right and left 3 units, right? If the larger denominator been with the x squared term, we go right and left because major axis be horizontal. So if we go up and down 3 units, right, what's up 3 units from 0, 0? We would have a vertex at 0, 3. And if we go down 3 units, we'd have a vertex at 0, -3. So again, it might help you as you're finding this information, just go ahead and start sketching it. Right, go ahead and graph what you have in front of you. So again, we're centered at the origin. There's 0, 0. Up 3 units. There's 0, 3. Down 3 units. Here's 0, -3. And again, you could go ahead and sketch it at that point. Right, major axis is vertical. There's that ellipse stretched out right along the y-axis. But there's a quick picture of it. Now, with that said, that was using the value of a. So remember, a tells us that distance traveled to the vertice. Now we got to also find the foci. So to get the foci, we got a little bit more work to do. So the foci, we need the value of c. So remember, we know a squared and b squared. So in an ellipse, c squared always equals a squared minus b squared. So in this problem, we got 9 minus 4, which is 5. So c squared equals 5. So as we take the square root, c is equal to the square root of 5. So there's our distance, which is an irrational number. We'll leave it as square root. That's what, 2 point something. But we'll leave it square root of 5 to be exact. So we would go up and down square root of 5 units. So we would add square root of 5 to the y coordinate of the center. So it would be 0 square root of 5. and we would subtract square root of 5 from the y coordinate. We want to go down square root of 5 units. So again, up 2 point something unit, we could plot them over here, right on our graph. So there's our point, 0, negative square root of 5. And here's the other focus, which is the ordered pair 0, square root of 5. So again, these are your foci for your ellipse, those 2 fixed points. But those are our key piece of information, right? Those are our center points, our vertices, and our foci, which again, we've found by getting our equation that was given to us in standard form. But the key is, remember, in standard form, we need to make sure we set it equal to 1, which we did. All right, let's go to another example. All right, let's move on. Now, in this next example, we're given an ellipse of x squared plus 2y squared minus 10x plus 8y plus 29 equal to 0. Now, with that said, it is an elliptical equation. We got the sum of 2 squared terms, but we notice the coefficients are not 1, right? They can't be reduced to 1 either, not both of them. So with that said, we are dealing with an ellipse, and we know, again, our standard form, our goal. Let's go ahead and write down what we want to see in the end with our equation. So we want x minus h squared over a squared or b squared, depending on, again, what the larger denominator is, will be where a and b is, and again, equal to 1. So again, these can switch up, but that's what we're looking for. Now, to do that, we got a little work on this one. We're going to have to create some squares with x and y. This problem, we don't have the squares given to us like our previous example. All right, we're not centered at the origin on this one. So what I'm going to do, I'm going to go ahead and rearrange my equation like I did earlier when we were doing the circles. Let's get the x terms together so we can create a square with x. Leave a little room. And then we'll do the y terms, 2y squared plus 8y. Leave a little room to create the square. And let's go ahead and move that 29 over. So subtract it over. That equals negative 29. And we know we need to eventually set it equal to 1. But before we do that, we got to work on creating squares. Now, one thing I like is we already have, right, a value of 1 here. So what we don't have, though, is our value of 1 with a y term. So that's important. So what you need to do in your next step is you need to go ahead and make that 1. So let's go ahead and do that beneath it. So x squared minus 10x plus, as we factor out the 2, we're left with y squared plus 4y. So that's important in creating a square. The coefficient needs to be 1, so let's factor the 2 out and make it 1. So now, right, we got the coefficients of 1, so we can easily identify half of b. So b, right, is equal to negative 10. As we divide that by 2, we get negative 5. So we're going to add in a negative 5 squared. Now, you got to do that to both sides. So I'd have to add in negative 5 squared on the right side. I'm adding in 25, keep it equal. But that allowed me to rewrite this quadratic trinomial easily. And let's do the same thing here with y. Let's create the square with it. So b holds the value of 4. So we take half of that, we get 2. So we're going to add in 2 squared. Now this is important. This coefficient we factored out goes with every term in the parentheses. So really we're not adding in just 2 squared. We're adding in 2 times 2 squared. So make sure you put that on both sides. So make sure we do the same to both sides of the equation. We're really adding in 8. Now we can rewrite this as a square. So let's go ahead and do that in the next step. And we're getting close to our standard form ellipse. So I got x plus half of b. So x plus negative 5. Right? All that squared. X plus half of b squared. That will give us x squared plus bx plus half of b squared back. So yeah, we square x plus negative 5. We're going to get x squared minus 10x plus 25 back. Plus 2 times, let's write the square, y plus half of b, y plus 2. Right? If we square y plus 2, we would get y squared plus 4y plus 4 back. Now let's go ahead and simplify on the right side. I got negative 29 plus 25 plus 2 times 4, which is 8. So let's go ahead and, while we're at it, write in our minus sign. X plus negative 5 is x minus 5. And y plus 2 is y minus negative 2. So you can already see what h and k are, right? Our x and y coordinates for the center. I'm rewriting these. Now the right-hand side, let's go ahead and add these up. Got negative 29 plus 25, that's negative 4. Negative 4 plus 8 is 4. Now, we're close. what do we not have? So remember, we got to set our equation equal to 1. So that's our next step. Let's set it equal to 1. So we need to divide out that 4 on both sides. So let's go ahead and do that. Let's divide our 4 out. So as we divide both sides by 4, we'll get it equal to 1 like we want it. So our equation now reads x minus 5 squared over 4 plus, let's reduce, 2 divides into 4 2 times, reduces to 1/2. So we got y minus negative 2 squared over 2 equal to 1. And there it is. There's our standard form, right, ellipse. So we got exactly what we're looking at for our ellipse. Now with that said, let's write in our key piece of information. It says find the center. Center being the ordered pair h and k. H being what's subtracted from x, that's a 5. K being what's subtracted from y in the y squared term, negative 2. So we're centered at 5, negative 2. Now, as we talk about the value of a, we talk about our vertices, which would allow us to sketch our graph. What does a equal? Now remember, the larger of the two denominators always represents the a value. So a is with x in this problem. So I'm going to make a little note. Our major axis is horizontal. So again, we're going to be going a squared is 4. Well, what's a going to be? So if a squared equals 4, we know that a equals 2. So we're going to be going, instead of up and down like our last example, we're going to go right and left 2 units. And why is that? Because our major axis is horizontal. A is with x. So if you're looking at 5, negative 2, right, what's right 2 units from 5, negative 2? We would add 2 to the x-coordinate. We'd be at 7, negative 2. And what would be left 2 of 5, negative 2? You subtract 2 from the x-coordinate. That'd be 3, negative 2. There are your vertices. So again, if you want to graph it, right, you could now easily get a quick sketches graph. So if I plot 5, negative 2, somewhere down here, here's our center. And if I go right and left 2 units, we'll put them in a different, well, we'll keep them black. If I go right 2 units, I'll be right here at 7, negative 2. Right? Here's 7, negative 2. And I go left 2 units, I'd be over here at 3, negative 2. And again, that's enough to sketch in my ellipse. Right? Now, our ellipse, again, stretched out, right, horizontally along the x-axis. Again, that's that value of a. A was 2 units. Now, our foci, let's go ahead and get the values of c. So looking at our foci, right, which is our last piece of information, those fixed points inside the ellipse, we need the value of c here. So remember, what's c squared? It equals a squared minus b squared. So in this example, that equals 4 minus 2, which is 2. As we take the square root of both sides, c equals square root of 2. So c is equal to the square root of 2. So we're going to go right and left square root of 2 units. So if we're at 5, negative 2, and we go right square root of 2 units, we'll be at 5 plus square root of 2, negative 2 at a focus. And if we go left square root of 2 units, we'll be at 5 minus square root of 2. So remember, you're moving from the center point. So again, you could plot in those 2 points here. So we'll look at these together. So here's 5 minus square root of 2, negative 2. And here's our other focus, which is 5 plus square root of 2, negative 2. Again, these are our foci, right, for our ellipse. So again, the key is getting in standard form, which we had to create the squares, right? We had to set it equal to 1 to do that, as we were looking at our elliptical equation. And you've got another example. So you can take this example. It's a major axis horizontal. Again, larger denominator was with x, right? And you can look at our last example in here, which is just like it, except I want you to notice what happens on this one. And we can go ahead and rearrange it. So I'm going to go ahead and put my x terms together. Let's go ahead and work through this one quickly. And we'll leave a little room. Let's put our y terms together. Y squared minus 2y. Let's move our constant term over. Subtract it over to the right side. We know we need to make sure coefficients of both terms are 1. Since it's not, let's factor it out. So as we factor that out, remember both terms with f of x squared plus 6x. And we've already got 1 here with our coefficient. so we don't have to worry about factoring on that one. And we identify b, right? B, again, the value of 6, so we take half of that. So we're going to look at 3. So we would add in, right, 3 squared here. So we add in half of b, and then we do the same thing over here. B is negative 2. So we take half of that, we get negative 1. So we would add in a negative 1 squared. And just remember, we got to do the same thing on the right side. So in this first term here, we had 3 squared was a 4 out in front. Don't forget that 4. That 4 multiplies with it. So we got 4 times 3 squared to add in. So 4 times 9 are 36. And nothing here, just the negative 1 squared. We didn't factor anything out on that one. But again, just setting it up, that's the key step. See, now you got your new quadratic trinomials that you can easily write as a square. And I'll do that in the next step. So I got 4 times x plus half of b, x plus 3, right, squared, plus y plus half of b, y plus negative 1, right, and what was b? Negative 1, or negative 2, we took half of that, so y plus half of b, y plus negative 1 squared, equal to, as we simplify on the right-hand side, negative 21, 4 times 3 squared, that's 4 times 9, or 36, plus negative 1 squared would be 1. So we're getting there. So as you want to, we would go ahead and put in the minus, x minus negative 3 squared, plus y plus negative 1 is y minus 1 squared. So we add these up, that's 15. 15 plus 1 is 16. And then we would have to set it equal to 1, right? That would be our next step. So as we do that, we would have to divide out the 16 on both sides, right, to make it equal 1. And we'd be done. We'd have our work in front of us. We'd have our standard form. So we got x minus negative 3 squared, so which means the x coordinate of the center is going to be negative 3, over 4, plus y minus 1 squared over 16 equal 1. So this time, our larger denominators will y. So if we talk about our major axis in this example is vertical. So to show you difference, so remember A is always greater than B. So with that, our center, let's go ahead and write our center point, H and K. So we got negative 3 and 1 for the center point. And as we're looking at the vertices, that's where we need the value of A. So what is A? What does A equal? So if A squared is 16, right, we know that A equals 4. So what do? Since major axis is vertical, we're going to go up and down 4 units. Right and left if it's horizontal, up and down if it's if it's with vertical. So negative 3, 1, what's up 4 units from negative 3, 1? We would add 4 to the y coordinate and put us in negative 3, 5. What's down 4 units from negative 3, 1? We would subtract 4 from the y coordinate. It'd be negative 3, right? 1 minus 4 is negative 3. There are your vertices. You could graph it at that point. Now your foci, you can do a little bit more work to get the foci. So the foci is the value of c. So remember, what's c squared? It equals a squared minus b squared. So it's 16 minus 4, which is 12. So c squared equals 12. C equals the square root of 12. Right? Got to take the square root of both sides. So we would go right and left. Now you could rationalize that if you wanted. That is 2 squared root of 3 rationalized. 4 is a perfect square factor of 12. But either way, and it might be in your answer key rationalize. Remember, rationalizing square roots, we look for perfect square factors. So we can take the square root of it. So it does rationalize 2 squared root of 3. So in your answer, if we're going up and down from the center, we would have a point of negative 3, 1 plus 2 squared root of 3. That would be up c units. And then we would have negative 3, 1 minus 2 squared root of 3 for the other focus. So there are your 2 ordered pairs, your 2 foci, right, for that ellipse. And you could sketch it if you needed it. But again, that's the key piece of information. There's a graph, right, for that. You can see a graph of that information here in front of us. It's written here in your PowerPoint. So I just want to show you, again, an ellipse and a circle. We're dealing with sum of squared terms. Now circle, the coefficients are both 1, ellipse, they're not. But again, the key is standard form. Once we get that, we can easily sketch it, graph it.